Okay, so this is attempt number 3 to record this lesson. Hopefully we get the audio. And you may be chuckling at this right now. So again, as a class lesson, this is going to be a little easier to do. So as a lesson, just kind of rewatch on the video, we're going to kind of guide you a little bit. So after reading page 7 and 8 in your book of Say It With Symbols, where it talks about equivalent expressions, what we're going to do here is we have these, we have a pool diagram here, and we are going to show you a diagram, and then we are going to try to come up with counting the number of tiles. We're going to show it to you for about 5 seconds. So I'm going to make this screen a little larger so you can see, and we're going to scroll it over here. When you see the pool, again, you have 5 seconds to kind of figure out the number of tiles, what strategy you use, and then we're going to come back over here and talk about it. So ready? Here we go. 1, 2, 3. Okay. So if you would have looked at the diagram, and again, you could pause the video, you could have cheated, you could have done anything, but the whole point is just kind of quickly trying to see a video. So if I would go back to the diagram, you could have looked at it and say, okay, well, if here's an edge and you counted 5, and you knew there were four edges, so that's 5 times 4, and then there were 4 corners, okay, you may have said that there were 24 tiles, which is correct. All right, so we're going to have a couple different examples here. All right, so the most commonly used one is saying, okay, well, there's 5 there, 5 there, 5 here, and 5 there, and then 1, 2, 3, 4. Okay, and that expression can be written as 5 times 4 plus 4, where this represents each side, right? There's 5 tiles and 4 sides, and then 4 being the corners. Okay. Another popular one, and again, these are kind of popular answers we've seen over the past, is to have an equation like this, where the 7 times 2 is a side from corner to corner. All right, because you got 5 in here, and then your corners are each worth 1, right? So there's your 7, and then the 2 of them, because you got 1 there and 1 up here, right? There's your corners. So there's your 7, 5 plus 2, basically, right? And then the 5 times 2, well, there's 2 sides of 5, and those are right here. Okay? So that's another expression that we could have come up with, as people get a little creative with it. A third possibility, let me scroll down here. A third possibility is to come up with, okay, if we go, each side has 7, meaning I'm going to go all the way across, okay, and then I go up the side here, so, but I overlap, right? So that's, we're overlapping, so we actually counted that twice, right? So we'll show you how we're going to take away that in a minute, and then we're going to go 7 to 7 here, which means overlap here. So we've overlapped twice now. And the last one is this side of 7, and we overlap twice here. So we've actually overlapped 1, 2, 3, 4 times. So a common equation here is to say, okay, well, 7 times 4, because from edge to edge on the 4 sides, and then we just subtract the 4, and those are the corners that we counted twice. Okay. And then the last but not least, which is kind of a different way to write number 2, a popular one has been 5 plus 2, so here's your 5 side, right? And then we add the 2 to it, being the corners, and you do that twice, all right? So 5 plus 2, plus 5 plus 2, plus 5, plus 5, okay? So this kind of lays the foundation, as now we try to find dimensions of different pools. Well, if you notice, the 5 by 5 pool basically meant that each of these sides within the pool were 5 feet by 5 feet. These pools are square. All right, so if we go to a 10 by 10 pool, notice these sides were right here. So we can replace that 5 and basically rewrite the equation with the 10, right? Because again, this side and this side is 10. This side and this side is 10. This side and this side is 10. And this side and this side is 10. So that's 40, and then 41, 42, 43, 44. So a 10 by 10 pool would have 44 tiles. Trying to keep the equation the same. So if this is 10, right? And now the corners that we count, add 2 more onto it. So that's 12, right? So this will be 12 times 2, because there's 2 sides of 12, right? And then we're going to add, so the 2 sides left now are these guys, which I have a dimension of 10. And there's 2 of them, so we're going to say 10 times 2. All right, so for the overlap, again, we're still going to overlap 4 times, but now, again, each distance is 12. So this should be 12 times 4, and then we're going to subtract 4 because we're going to count the corners an extra time, right? And the bottom one, again, we're going to replace the 5 with a 10 because the pool dimensions have changed. So 10 plus 2 plus 10 plus 2 plus 10 plus 10. Okay? So now when we go to the bigger pool, the 27 by 27 pool, again, finding similar equations to what we had, just changing it with the dimensions. Okay? So again, we have 4 sides of 27. And then we're going to add 4 to it for the corners. Okay? So you can see the sides change as the dimensions of the pool change. Right? Everything else stays the same. So now at 27, well, if we go to number 2 and try to do it the same way, well, now all the way across is not 27, it's 29. So there's going to be 2 of those, 1 there and 1 here. And then these 2 sides right here are 27, and there's 2 of those. So 27 times 4, to find the number of tiles, is 108. And when I add 4 to it, we get 112 tiles there. All right, on the bottom, now that we're going to go the full length, right, and we know that the full side from corner to corner, from edge to edge, is 29. So there's going to be 2 29s, right, here and there. And then we got these 2, which are 2 27s. And on the bottom, we're going to switch out the 10s with 27s. 27 plus 2 plus 27 plus 2 plus 27 plus 27. So you can see by changing the dimension of the pool, we can change the expression a little bit. Okay? So now that we've done that, the whole point of this is to try to find equivalent expressions. So we're going to come up with an equation from these guys right here, and then see if all 4 equations are equivalent. So in the first equation, we have 4 sides. So if we're trying to find the number of tiles, okay, you have 4 sides, right? So whatever the side length is, right, whatever the side length is, we multiply by 4. So there's your 4 times S, because whatever the side length is, there's 4 of them. And then you got to add 4 in for the corners, which is going to be plus 4. So our equation for that first row is 4S plus 4. S equals your side length, and obviously N will be the number of tiles you need to tile the pool, the edge, the border. Now the second one, okay, we have a side length here, right, which we found out, right, and then we added 2 to it. All right, so if I start to make my equation, we have a side length plus 2, and then there's 2 of those. So this expression, we're going to multiply by 2, because side length plus 2, and there's 2 of them, all right? And then we added, basically, there's 2 other sides to it, right? So we're going to add 2 sides to it. So that equation is 2 times parentheses S plus 2 plus 2S. That's how we can use this equation to find certain lengths here. Now, in the second one, and actually, I just realized what I did wrong. Holy smokes. You probably caught me already, but this equation is way off. This equation should be 29 times 4 minus 4. Wow. So, in this equation, right, to find the number of tiles, we'll write it over here. So again, I counted tile to tile, right? All the way across. Right? That length was 29, right? Well, I can write 29. That's a side length. And we did it for 4 sides, right? Okay. And then we did it this way. And again, that side was 29. But again, we overlapped one time. Well, then we went this way, right? And we overlapped again. And then we went this way, which was a whole length. And that overlaps twice. So again, we overlap. We basically count the edges twice, so we're going to subtract the 4 from that. And actually, I think I got this. We got to fix this a little bit here. So this is going to be n is going to equal. So this is going to be basically this is 4. This is going to be 4 times the side length plus 2, right? Because you're going edge to edge. So the s plus 2 is kind of like up here in row 2, where you got the side length, right, of being, you know, whatever it is. And then adding 2 to that, which means it's corners. And we do 4 all the way around. And then outside of that, we're going to subtract the 4 from it. Okay? Because we count the corners twice, basically all the way around. There's 4 corners. So we take the 4 out to even it out. Now the bottom one's a nice easy one, just because you're going to have a side length plus 2, plus a side length plus 2. That adds your 2 corners on. And then you just add the 2 sides to it. All right, so we've come up with these equations to basically find out if they're equivalent or not. So if I go to the bottom here, and I write those 4 equations in here. So the first one, even though we covered it up, that was n equals 4s plus 4. Number 2 is n equals 2 times s plus 2 plus 2s. The third one was n equals 4 s plus 2 minus 4. And our fourth one is n equals s plus 2 plus s plus 2 plus s plus s. Okay, so I have 4 expressions here. And just by the eye test, and what I mean by the eye test, just by staring at it, do these equations look equivalent? And your answer is probably going to be no, which you're justified in saying that. Because, again, if you just stare at those and look at those for what they are, they do not look like they're the same equation. So what our job is going to be to do is to break it down using our algebra skills and simplify these expressions and see if they are or not. So here we go. So in the first one, this guy right here, we can't break that down any further. All right, we got 4s plus 4. There's no like terms to, or anything to combine. So it's kind of a lost cause. So as I'm teaching here, I'm going to walk up here and crack the door because we have a lot of hallway noise, and I don't know if the microphone is picking it up, but we want to try to minimize the noise so you can concentrate. So in the second problem, let's use our algebra skills. We are going to distribute the 2 into s plus 2. Okay? And when I do that, I get n equals, well, 2 times s is 2s, and plus 2 times 2 is 4. And I bring the other 2s down. Well, I have like terms of a 2s and a 2s. So when I add them together, 2s plus 2s is 4s. And I get 4s plus 4. And look what happens here. This expression simplified happens to be the same expression as number 1. So since we broke it down and these are the same things, number 1 and number 2 in its original form are equivalent. Meaning they are the same expression, just written in a different way. Because when we simplify it down, they're the same equation. Exactly the same. All right, let's go to number 3. So number 3, we're going to distribute the 4 through. So 4 times s is 4s. 4 times 2 is 8. Bring down the minus 4. Okay. And I can't do anything with the variable because I don't have any other variables to combine with, but positive 8, so in minus 4 we can combine. And 8 minus 4 is 4. So again, after I break this one down all the way, we notice that 4s plus 4 is the same as numbers 1 and 2. So again, these guys are equivalent. So 1, 2, and 3 are equivalent expressions. They're all the same thing, written in different ways. Well, if we go to number 4, we just have a lot of like terms to combine, right? I have an s, an s, an s, and an s. So that's 4s. All right. Then if I go to find my other 2, I got a positive 2. So I have and a positive 2, so a 2 plus 2, which is 4. And that helps complete the circuit because, again, these guys are the same, which makes basically all these equivalent. So because we simplified these down and got the same equation, n equals 4s plus 4, so equations 1 through 4 are equivalent. And what we found is basically a general equation that we can use to tile any border around a pool of any dimension by using the equation the number of tiles n equals 4s plus 4. So if we got any dimension of a pool, and it would have to be a square pool. Obviously, if it was a rectangle, it would be a different dimension. But this would be how we could find our answer. So I hope you found this lesson to be helpful and kind of helps tie it together. So the whole point of doing this wasn't necessarily to find the equations. It can show you that there are more than one way to write equation, and sometimes even though they don't look the same, they can be equivalent. So again, I hope you found it helpful. And remember, if you need any help, you can always see Mr. Vitale or Mrs. Dietz. You can't be afraid to ask questions. So hopefully you found this video helpful.